today for SARM Supplier Spotlight webinar on drainage products and solutions with Armtec. My name is Adam Brome, and I'm a Communications and Events Coordinator with SARM. We'll start off today's session, as always, with a few quick notes regarding the webinar's platform functions and session format. We'll then transition into the main session, or main presentation, which will be followed by a Q&A session. This webinar will be recorded, and a copy of the recording will be available to view on our webinar's webpage following today's session. Please let us know if you're experiencing any technical difficulties during today's webinar through the chat. The chat box is located on either the top or bottom portion of your screen. Click on the comment icon or the comment bubble icon to view and participate in the chat. The chat is visible to all webinar participants and presenters. The chat is also where you can submit any questions that you may have for the question and answer session. All questions will be answered following the presentation, and if we do run out of time before your question has been asked, we will follow up with attendees after the session to provide responses directly. And we will also be distributing today's presentation and the recording to all attendees and anyone who has registered via email following the webinar. And again, if you're experiencing any technical difficulties during today's event, please let us know through the chat and we will do our best to troubleshoot. And with saying that, I'll now hand it over to Amanda Kozak, SARM's Member Purchasing Advisor, who will be moderating today's webinar.
Good morning, everyone. Today we have Lisa Ryland and Jason Sutton who will be presenting for us this morning. Lisa Ryland is a Regional Sales Manager in Saskatchewan. She's based out of Saskatoon. Lisa joined Armtec branch at the WGI Group in 2019 as the Regional Sales Manager for Saskatchewan. Lisa's primary focus is client liaison between the Saskatoon and Regina manufacturing facilities. She is the first point of contact for product-related questions or any general inquiries. Prior to joining WGI, Lisa worked as a consulting engineer in the environmental industry, specializing in contaminated site remediations and risk management. We also have Jason Sutton with us today, and he is the Sales Director for Western Canada. Based out of Edmonton, Jason joined WGI with Canada Culvert in 2016 as the National Director of Sales. Following the acquisition of Armtec in 2018, he took the role of Sales Director in Western Canada to more strategically focus on customer support and business development for Western provinces. Prior to joining WGI, Jason began his career with GE Capital for 10 years as a regional manager, followed by 8 years as National Sales Director with All Weather Windows. And now I'd like to hand it over to Lisa.
Thanks, Amanda. Again, thank you for everyone taking the time to attend this webinar. As Amanda mentioned, my name is Lisa Ryland. I'm the Regional Sales Manager for Saskatchewan. Today's webinar will include a brief introduction to Armtec's scopes of services, corrugated steel products and accessories, high-density polyethylene culverts, buried bridge structures, our patented bridge in a box, and our bin wall retaining. Armtec manufactures a complete range of water control infrastructure products, making it a trusted partner for public works, forestry, RMs, oil and gas, agricultural, and mining operations across Canada. Of the 31 Armtec locations across Canada, 2 are situated within the province of Saskatchewan to meet SARM members' needs. In the event a product isn't available in either Saskatoon or Regina's standing inventory, we can leverage our distribution network in order to bring it to one of those locations or directly to your job site in the most timely manner possible. While Armtec is known as an industry leader when it comes to steel, everyone, including Armtec, had to start somewhere. Excavated in Manitoba prior to corrugated steel, this is what culverts look like. And like every industry, over time, both the materials and the manufacturing method for culverts have evolved from hand-assembled oak and banding to a mechanized system where large coils of steel are placed on a mill system, which is then formed into culverts with helical corrugations and a continuous lock seam. The combination of the helical corrugations and continuous lock seam combines high compressive strength with a lightweight, thin-walled structure. As you can see from the photo on the right, this culvert has both helical and annular finishings. The annular end, which is also known as a record end, is done for ease of joining two separate pieces of culverts into a longer length. In general, the CSP sold to SARM members range from as small of diameter as 12-inch or 300 millimeter up to 12 feet or 3,600 millimeter. Depending on the location and design, wall thicknesses can be anywhere from 1.6 millimeters up to 4.2 millimeters. While not currently manufactured in Saskatchewan, we can also bring in from other Armtec locations as small as 6-inch or 150 millimeter, 8-inch, 200 millimeters, and 10-inch, 250 millimeters. When selecting a culvert, the intended service life based on site-specific soil and water conditions should be taken into account. The 4 key parameters that will affect the service life of your culvert are local pH, the resistivity, more commonly known as the amount of dissolved solids in the water, hardness, which at elevated levels can actually increase the service life of your steel culvert through a protective scale formation on the metal surface, and chlorides, which are commonly found in de-icing salts, which decreases the culvert lifespan by accelerating steel corrosion effects. As shown above, we have 3 types of coatings available, and they each have an optimum operating range. As we go through the 3 coating types, I might be flipping back and forth between this slide and the previous slide. As you can see, we have standard galvanized, which is the standard finish for most culverts ordered by the RMs. And depending on insulation and local conditions, you can expect a 40 to 50 year service life. The next one is aluminized steel type 2. It's an economical alternative to concrete pipe, and it, depending on site-specific conditions and installation, can have up to a 75-year service life. And lastly, we have our polymer laminate coating. It's a premium product and suitable for all Canadian soil and water environments, and has up to a 100-year service life. And as you can see on this slide, we have the pH ranges, which show polymer laminate operating from about 2 to 12, the aluminized type 2 falling right in the middle range, and then the galvanized a little bit right up the middle. Resistivity, polymer works across the board. The aluminized is more optimized towards the right half of the graph, whereas galvanized has a very narrow range of optimal conditions. Hardness, polymer, and aluminized are equivalent. The galvanized is more optimized on the right-hand side. And lastly, for chlorides, the polymer operates for all ranges, while the aluminized and the galvanized are suitable on the left-hand side of the graph. Coupler-wise, our standard annular couplers are the most commonly requested type by SARM members. They come in either a single wide or a double wide type for most sizes, depending on user preference. Please note, you do not want to over torque the couplers, because when that occurs, you'll notice a slight bend on the right-hand photo, whereas on the left-hand coupler photo, that one has been tightened correctly and there's no deflections present. In addition to the standard annular couplers, Armtec also carries specialized couplers, which attendees may or may not know about. We have dimpled couplers, which are used to connect a helical pipe end to an annular type end. This connection is most often required when a previously damaged culvert end has been saw cut off in the field and a new extension piece needs to be attached. Hugger bands are equipped with O-ring gaskets and provide a tighter connection between the 2 pipes in order to minimize water leakage at the joint and mitigate potential pipe settlement. These hugger bands are ideal for use beneath roadways with higher soil cover heights. Lastly, we also carry internal annular couplers, which are routinely used for large diameter relining applications and interior sleeving applications. In addition to regular pipe, Armtec's team of custom fabricators can construct a variety of elbows, keys, risers, bulkheads, and saddles to meet site-specific tie-in needs. The photos on this slide show some of the more common fabrication requests Armtec has provided to SARM members over the years. You'll note that on the right-hand photo, the finishing along the joint is a gray matte type color rather than the shiny galvanized coating. While aesthetically different, this cold galvanized coating is 93% zinc rich and provides protection equal to or better than hot dip galvanized spec. There is an additional type of paint that can be applied for aesthetic matching of the shiny galvanized appearance on the rest of the pipe if needed. In addition to steel culverts, Armtec also manufactures high-density polyethylene, commonly referred to as plastic culverts when ordering. Our Boss 2000 product line is proudly manufactured in Canada, and the CSA B182.8 spec for the 320 kilopascal type strength. Pipe diameters are available from as small as 100 millimeters up to 900 millimeters, and our standard stock lengths are typically 6 meter, 9 meter, and 9.5 meter, dependent on diameter requested. Our HDPE culverts are low weight, but they allow for quick on-site cuttings with typical construction tools. There's no specialty blades needed like there is for the steel. They are pH resistant from 1.25 up to 14. So basically highly acidic to highly caustic environments. It's suitable for use. As well, it comes equipped with a smooth wall interior, which allows for optimal water flows. Like its steel cousin, the Boss 2000 has a variety of couplers to choose from depending on site-specific needs. Our external split coupler is the most often type requested by SARM members and provides a soil-tight feel. The external double band snap coupler is for specialized limited use settings as it's only available in 100 and 200 millimeter diameters. And lastly, the ultra stab coupler is for watertight applications and typically used for storm water systems. This slide provides a sampling of the various types of connections and fittings available for the Boss 2000 product line. As is the case with steel, the Boss can also be custom configured to your individual needs. While not all culverts installed have end treatments, the benefits of their use cannot be understated as they reduce inlet scouring and outlet undermining effects. In general, 3 types of end treatments are most often requested by SARM members, and they are our CSP end sections. They are prefabricated step beveled pipe ends, which reduce the scour effects on the inlet side and undermining effect on the outlet side, and are available in standard sizes up to 2400 millimeter round diameter and 2130 by 1400 pipe arch size. We have our Pro Eco Light head wall, which is comprised of a polymer concrete. It is also compatible with racks, grids, handrails, and gates. And lastly, we have the steel sheeting cutoff walls. These are typically used for large culverts and buried bridge type structures, which I'll discuss later in this presentation. They require site-specific engineered design for usage, but are generally installed approximately 1 to 1.5 meters below the invert. Depending on your site needs, Armtec can also provide culvert accessories such as culvert markers, which are compatible with both Armtec and competitor type culverts. end grates to prevent animal or human entry into the culverts, and custom fabricated fish baffles. Culvert markers are kept as standing inventory at both Saskatoon and Regina locations, while the end grates and fish baffles both have lead time for availability attached to them. Armtec currently has two different types of Beaver control products available depending on site conditions. We have our Beaver stop line, which is available from 400 millimeter up to 2400 millimeter. And I need to put a caveat on the 2400. The Beaver stop is currently at redesign, so the maximum diameter may be changing. It can be adapted for arch culverts, concrete pipe, and HDPE use, and it allows fish passage. We also have the flow guard, which is available from as small as 150 millimeters up to 3000 millimeters, and from the 450 by 340 to 1880 by 1260 in the pipe arch system. Our flow guard is also compatible with concrete, high density polyethylene, and PVC pipe, and also allows for fish passage. Armtec distributes Waterman water control gates, which are available as prefabricated or customized options. A sampling of the gates, typically ordered by SARM members, are shown on this slide. Depending on what part of the province you're from, the photo on the left may look familiar, as Duramax was utilized by Sask Highways for their bridge widening project on Highway 16 East near Dafo. Now that the Quill Lake water levels have slightly subsided, the Duramax pipe ends are now visible on both the east and west directions of this crossing. As you can see on the right-hand photo, Duramax is comprised of exterior steel ribs encased in high-density polyethylene. Duramax is available in diameters as small as 750 millimeters up to 3000 millimeters and has a smooth wall interior. This product is most often used for culvert relines, underground stormwater detention tanks, stream and canal enclosures, and harsh soil and water environments. While end treatments, culvert accessories, Beaver control, water control products, and Duramax are not. Oh, sorry, that one slipped in. The Duramax performs as steel pipe, is designed per AASHTO Section 12 LRFE design methodology for culvert. This is not a thermoplastic pipe. The HDPE material present in Duramax is to provide corrosion resistance and a smooth waterway wall and joint options typical of HDPE. If you'd like to learn more about the Duramax product line, please reach out after this session. Depending on what area of the province you're from, this crossing may look familiar. For RMs that may still have timber bridges which have reached their end of service life, a buried bridge structure may be a viable option as their replacement in lieu of precast concrete or timber. Armtec currently has two structural plate options available: deep corrugated structural plate, trade name bridge plate, and shallow corrugations or structural plate CSP, trade name multi-plate. As this photo illustrates, bridge plate has a much deeper corrugation profile than the multi-plate, and this translates to approximately 10 times the plate stiffness and greater than 4 times the moment of resistance in relation to multi-plate. Multi-plate was first invented by Armco, present-day Armtec, in 1934. Various shapes and sizes are available, which makes the multi-plate versatile and customizable for most applications. While available in diameters as small as 1.5 meters up to 8 meters, arch spans from 2 meters to 6 meters, multi-plate structures are generally a competitive product option in arch spans from 3 meters to 5.5 meters. Installation and design of multi-plate structures falls under Section 7 of the Canadian Highway Bridge Code. Bridge plate is most commonly requested in arch, box, or round shapes, and there is a large selection of standard sizes to meet most applications. Arches are available in 3 shapes: single radius, low or high profile 2 radius arches. Box culverts, with their low rise to span ratio, make them ideal for low headroom, low cover applications. While round structures, as their name implies, are available in full round sizes from 6 meters to 12 meters in diameter. As with multi-plate, the design of bridge plate also follows Section 7 of the Canadian Highway Bridge Code. Both multi-plate and bridge plate are transported in appropriately bundled plate stack separated by dunnage. As the first image shows, the plate corrugation stack nearly perfectly. From that initial stack, the plates are then pre-assembled to correlate with the sequence provided by Armtec issued for construction drawing. As assembly progresses, the initial stack of plates is transformed into a buried bridge. So now we're going to get to the good stuff. We've got some case studies. First up on our case studies is the Sask Highways installation on Old Highway number 2 in the RM of St. Louis, and involves 1 single radius arch, 9.75 meter span by 4.89 meter rise by 42.08 meters in length. A cast in place concrete footing installed below the stream bed was installed with stem attachments, which is where the arch structure was ultimately attached to. As well, concrete collars are utilized to provide stiffness and end protection on both the inlet and outlet ends of this system. Our second case study is in the RM of Arborfield. This one is also a single radius arch bridge plate material, has a 10 meter span by 5 meter rise, and is 51.6 meters long. As was the case for the McKay Creek on Old Highway number 2, this crossing also utilized cast in place footing installed below the stream bed. However, this design also incorporates steel sheeting on the inside of each footing as an added layer of scour and undermining protection and prevention. Concrete collars were also utilized in addition to a beveled end to provide additional protection against ice and entrance in the system. Our next case study is from the RM of Garden River. This one, you'll see that the arch is slightly lower because it is a 2 radius bridge plate arch and has a 12 meter span by 5 meter rise and is 20.4 meters long. Unlike the previous 2 case studies, this one is also equipped with a mechanically stabilized earth welded rock face with geogrid soil reinforcement. In general, these 2 radii arches are typically used for lower profile, lower clearance crossings. Unlike the previous case studies, this location utilized precast concrete footings to save the contractor time on site. The steel sheeting was also again installed at this location as a preventative measure against scour and undermining. Our next case study is on Highway 905 and was installed for Sask Highways. These are 3 identically constructed crossings. As was the case for the RM Garden River previously, these crossings are also 2 radius arches. However, they are narrower and shorter than Garden River. Cast in place footings were installed below the stream bed and were installed at all 3 crossings. However, the designer in this case did not include any steel sheeting on the inside of the footings, but they did include the same type of MSE rock face with geogrid soil reinforcement. Our next case study is the RM of Indian Head. This single radius bridge plate arch measures 7.5 meters span by 64.8 meters long, and it has an equivalent end area of about 22.7 square meters. This structure was installed to replace an existing 2,700 millimeter standard culvert, which only had an equivalent end area of approximately 5.7 square meters, which had failed. Upon completion, this crossing had approximately 8.1 meters of soil cover, making it a deep cover type crossing. You can see the ends are also beveled, which will assist in managing water flows to allow more water to pass more quickly. Now if you've been up in the northern part of the province, you might recognize this crossing as it is at the Pine Cove Marina subdivision. Pine Cove utilized a full round type bridge plate structure, 6,885 millimeters in diameter by 40 meters long. These full periphery round structures eliminate the need for engineered footings and foundations, making these an earthworks type installation. This crossing is located in the RM of Loon Lake and is located beneath highway number 26. It was constructed in order to provide boat access from a newly constructed subdivision through a channel directly into Mackwa Lake. And last of today's case studies is Sask Highway's installation on highway number 22 and involves a single radius arch. Oh, sorry, my mistake. It is a full periphery round multi-plate structure. It replaced a pair of undersized culverts. Again, concrete collar and cut-off bolt were utilized to provide stiffness and protection against ice and end drift. And the photo on the right-hand side is one taken about a month ago when I was driving down Highway 22. So you can see that it's still, it was actively flowing with water and has been holding up well. In the event a buried bridge structure isn't suitable for your crossing due to the water hydraulics or permitting requirements, a bridge in a box may be a viable option. Utilizing bridge in a box over a conventional precast concrete or timber structure has cost savings to the RM, as the bridge superstructure is already pre-engineered, which can eliminate that aspect of the consultant's design fees. The system is modular and is delivered pre-assembled in large sections, saving the contractor installation and assembly time on site. The superstructure itself is typically installed in 1 day or less. They are also well suited for rural and forestry roads and other remote locations. The bridge in a box is suitable provided the following conditions and parameters are met. That it's being installed on a low traffic volume road as defined by the Canadian Highway Bridge Code. That the bridge deck height is only 5 meters or less above the water surface. Live load vehicle ratings do not exceed CL 800 or L 100. And lastly, the bridges can be configured into either single or double lane widths to a maximum width of 28 feet or 8.5 meters and a maximum length of 80 feet or 24.5 meters. There are a number of different finishing options available for the bridge in the box, which allows the RM to customize the crossing to their individual needs. These finishings include various decking options, such as unpaved, cast-in-place concrete, asphalt, timber. There are different coating and finishing options, which include weathering steel, galvanized, painted, and guardrail systems to choose from. A TL1 system, which is not crash tested, W-beam, Thri-beam, or timber wheel guards. However, those require the RM to accept. In general, the RM's bridge consultant of record, sometimes identified as the global consultant, oversees the abutment design, as well as the geotechnical soils investigation and hydraulics assessment, as site-specific soil conditions determine the type of abutment design that is ultimately selected. Bridge in a box is compatible with a variety of foundation options, including spread footings, precast sills, cast-in-place concrete, MSE walls, bin-type bin wall retaining walls, or pile foundations. Our tech engineering and design services team will work closely with the owners bridge consultant of record to assist with this design. Our first bridge in a box case study is from the RM Moose Creek. This bridge in a box is located southeast of Carlisle and was installed in March 2022. It is a double lane, 28 foot in width by 60 foot in length. Based on the geotechnical drilling results, the global consultant determined the best abutment design would be galvanized steel pipe piles with galvanized steel deck planking. Our next bridge in the box study is from the RM of Brock, and they installed 2 of them. Our first bridge in box for RM of Brock is located near Kisby and was installed in January 2018. It is also a double lane bridge, 28 feet wide by 50 feet in length. This structure is equipped with timber wheel guards to allow for over-width agricultural equipment to utilize the crossing without causing unnecessary damage to the bridge. Based on the geotechnical results, the global consultant for Brock determined the best abutment design would also be galvanized steel pipe piles with galvanized steel deck planking. Our second bridge in the box for the RM of Brock was also located near Carlisle, Saskatchewan, and was installed in December 2018. It has a slightly narrower double lane configuration of 24 feet wide and is slightly longer at 60 feet. Based on the geotechnical results at this location, the global consultant is actually able to reuse the previous abutment design they used for the other Brock crossing. Our bridge in a box superstructure is transported to site via flat deck semi. Cranes already staged on site are utilized to lift and place each bridge in a box piece via strategically placed lifting lugs. Placement of the pieces typically takes 1 day or slightly less, with the necessary bolt connections and welding taking place over subsequent days. Our last product I'll be discussing today is our bin wall retaining system. This photo shows bin walls being installed at a waste transfer station. Upon completion, roll-off bins would be staged on the left-hand side of the bin wall structure, while on the right-hand side, vehicles will drive up the ramp and be able to dump their load over the side downward into the bin. Bin walls can also be used for other applications, as they are closed-faced rectangular bins with 4 sides and no bottom containing compacted soil. The interior compacted soil transforms the front face into a flexible gravity-type retaining wall. Bin-type retaining walls can be used for bridge abutments, as they are an excellent choice for remote sites, as the components are easily transportable, palletized, and can be quickly assembled without the need for heavy equipment or cranes. Prior to speccing bin wall for bridge abutment use, additional information is required, including the bridge span, road width, the live loads, the bridge dead load, and abutment height. And we have a case study here from the present day Star Diamond Corp near Fort Alicorn, Saskatchewan. And we have a cameo from our own regional engineer, Ron Prohico, in the right-hand photo. These bin walls were for a single lane by 60-foot steel bridge. And in conclusion, if you would like to learn more about what goes into the evaluation and selection of buried bridge structures, the bridge and box system, or bin walls, we can talk with you and your consultant regarding which product lines will work best for your site. These photos are of the previously discussed Burrell Creek site, and you can see that the 2 undersized culverts and the subsequent road washout, and then a photo taken immediately after substantial completion was achieved. At this time, I would like to open up the Tech Talk for questions.
Okay, so it looks like we have a few questions here in the chat box. The first one I see here is, what are the main differences between the 210 kPa rated HDPE culverts and the 320 kPa rated HDPE culverts?
Jason, I can take this one if you want.
No, you can certainly answer the technical portion. I want to thank Amanda and everybody for joining on the live session, as well as those who are going to watch this via the library. With the HDPE, Saskatchewan's the only province in Western Canada, actually, and I just wanted to mention this real quick, where we manufacture both steel and HDPE products. Our HDPE location is in Saskatchewan, in Saskatoon, and our steel production is in Regina. That allows us to have quick turnaround on production, ensure we have inventory on both products. There are two different specifications of HDPE pipe, being the 320 kPa and the 210 kPa, and I'll let Lisa quickly respond regarding those two differences.
So the 210 kPa is typically utilized by forestry and RM for typical roadway crossings. It's and the 320 is used for crossings requiring a more robust construction and watertight requirements. It loosely the equivalent of 210 kPa HDPE to 1.6 wall thickness steel, and the 320 kPa would be loosely equivalent to 2.8 wall thickness steel. So if you have any questions, you can just reach out at the time of voting, and we can run through it in greater detail.
The 210 kPa does include some recycled content versus the 320, which is all virgin material, which is required for CSA certification. However, the burial depths for application are very similar, if not identical, for the two different types of HDPE pipe. The 320 does come with a bell option. Typically, the 210 is also a stick. It doesn't have a bell end, so you would use a coupler instead of a built-on joining, which would be a bell and gasket application. But we can provide more information about that at any time to any of the members who want to know more about the differences in steel versus plastic, or the differences between the 210 and 320. Both are manufactured in Saskatoon, and both are, we keep a good inventory and stock of both, which is a little bit different than the steel as well, because the production is different on plastic. So you create a large inventory. That's beneficial in that the other positive aspect about HDPE pipe is we always have the material on hand. So if there's short-term needs, the turnaround time to fill those orders is very, very easy out of the Saskatoon location.
Okay, thanks, Lisa and Jason. Another question that has come up is, what is the cost of the HDPE versus the corrugated?
Jason, do you want to take that one?
Sure. HDPE is typically the easiest way to look at the difference in pricing. First off, the performance is very similar. HDPE obviously is not steel. So if you are dealing with different types of soil conditions where you might need a polycoat, and we do see a lot of issues requiring soil conditions requiring coatings on steel. HDPE, of course, because it's made out of HDPE, it doesn't require that. From a cost standpoint, typically anything that's 600 millimeters in diameter or smaller, you'll start to see more cost benefits with HDPE pipe versus steel. Obviously, with raw materials, prices can fluctuate. However, HDPE in the smaller diameters is typically a more cost-effective solution. And then when you're talking about 320 versus 210, the 210, because it does have some recycled content to it, allows us to make it even more cost-effective. So for smaller diameter, for non-320, for example, highway use, or if it's specified for a 320 kPa, the 210 in smaller diameters is a very cost-effective solution.
And a lot of times this year, when the RMs have been approaching us for feasibility or budget pricing on steel, we've also been including the 210 kPa pricing for their reference, just so that they can see at that time, like in black and white, the cost difference.
Another question here, if I order Armtec products directly through SARM member purchasing and Canoe, will my project still be compliant with the ICIP, RIRG, and the PDAP type funding programs?
Yes. We actually just assisted the RM of Moose Range with a PDAP project for a large buried bridge structure. They received the materials last fall, and they're hoping to install them this year.
All of the products that we presented today were part of the tender process to participate with the SARM procurement program. So we're very happy to have continued to be a part of the SARM purchasing program. We've been with it for a few years. This year, we've added HDPE. So all of our products that were presented today and all of the products we produce in both Regina and Saskatoon have been vetted through the tender process and are eligible for purchase through the SARM program.
Great. Another question here. What, if any, are the heights of cover differences between steel culverts and HDPE culverts?
I can take that one, Jason. They both have the same height of cover requirements. The difference is a lot of public works make the incorrect assumption that they don't need as high of height of cover on steel culverts, when the reality is both steel and HDPE both have minimum cover height requirements to ensure service life and performance expectations are met.
There's a bit of a misconception that it's the thing that transfers over it. But as we all know, it's the actual backfill and the structure, the arch structure that's created through the backfill process that forms that arch that carries the weight. So people will look at plastic and steel and think, well, steel is stronger. It will actually perform better with less height of cover. That's a bit of a misleading assumption. You do want to continue to follow the minimum height of cover requirements to meet the load ratings. And for steel and HDPE, they're very, very similar, if not identical.
Okay, what lengths are HDPE culverts available in, and can they be cut to size in the field?
I can take that. Standard stock length for typical RM diameters required are 6 meters and then 9 to 9.5 meter length. So Armtec has recognized that field approaches have gotten wider over the years due to the size of agricultural equipment increasing. So that's why we've moved toward offering the 30-foot range as a continuous pipeline for the plastic culverts.
The benefit of HDPE, because the production process is much slower, we have to build the inventory. So whereas steel, you can order differing lengths and we can make custom lengths coming off of the mill. HDPE pipe is manufactured in batches. So it allows us to create a large inventory of the product, but it limits our ability to carry multiple sizes. The benefit is it can be cut very easily in the field. You can use a saw, it's lightweight, you can move it quite easily, and it has more options to modify the lengths as required in the field versus steel.
Okay, great. I don't see any other questions here. So if that's all the questions for today, then I think we'll wrap up the webinar. I want to thank everyone for joining us today, and thank you to Lisa and Jason for your very informative presentation. It was great. So
Thank you for having us, Amanda. Really appreciate it and value our partnership with SARM.
Thank you, everybody. Have a good day.
Thanks.
Bye-bye.